Hello, my name is Jerry Walsh. I'm a senior here at Ohio State University, and I was assisted on this project by Dr. Laura Kabako. And we've been working on this since the start of 2021, and we're excited to share with you all what we have today. So, an analysis on SARS-CoV-2 in wildlife. In the state of the pandemic, according to the WHO, as of November 8th, 2021, there's been approximately 250 million cases of COVID-19 in humans globally. There's been approximately 5 million deaths of COVID-19 in humans globally, but very fortunately, there's been 7 billion doses of vaccines administered globally. And this number is total number of vaccine doses given. So this counts too for people who've gotten 2 doses, and as well as it also counts people who've been partially vaccinated. And it's fair to say that COVID-19 has changed the way we live our lives, and now we have to do things over Zoom, such as this entire research festival. And if we were meeting in person, we likely would be having to wear masks for safety. But it's fair to say COVID-19 has changed the way we live and will continue to change the way we live the rest of our lives. So SARS-CoV-2 in mink. When the pandemic first broke out, a lot of people were worried about what animals could have COVID. Could I catch COVID from those animals? Can my pets get COVID? But one animal stood out among all of them. And that animal is the mink. The mink is just a small mammal. It's very similar to a ferret, and it lives in North America as well as Europe. And mink was in the news a lot because mink were getting COVID on farms and then giving COVID to humans, as well as spreading it to other minks as well. So here are some news headlines. So we have coronavirus outbreaks at European mink farms show virus may pass from animals to humans. Sky News of August 2020. Coronavirus in Denmark, shaken by cull of millions of mink. So this means that all these mink were having to be killed strictly because they were catching coronavirus and spreading it to humans. Mink are catching the coronavirus on farms, including the one in Oregon by OPB in December of 2020. And this last one by Munich is a peer-reviewed source, and it's the transmission of SARS-CoV-2 on mink farms between humans and mink and back to humans. And that one was published in early January 2021. So because mink were in the news, a group of people here at Ohio State were particularly interested in what other animals could be having COVID-19 here in the United States. So because of that, eScout was formed. eScout stands for Environmental Surveillance for COVID-19 in Ohio, Understanding Transmission. So eScout is just a group of people here, and our goal is to form relationships within the industry to conduct surveillance on SARS-CoV-2 in the wild, as well as assess the possibility of human infections due to animal reservoirs. So eScout had some people going out in the fields testing animals, and then had people like Dr. Kabako and I who were tasked with modeling all this information and then presenting it. So what Dr. Kabako and I did is we developed a program in our studio using many things such as GBIF, which houses occurrence data, BioClimb is an online database which houses climate data, and then data collected internally through eScout, and a program called MaxEnt, which you can kind of see here on the right-hand side. MaxEnt simply is a package in R that allows many things to be combined to predict the likelihood that a given animal will be at a given point anywhere in a given point in time. So on the right-hand side, you can see it's Ohio, and all these black pluses are going to be where it doesn't think the animal is going to be. And all these red pluses are going to be areas where it thinks the animal is going to be, but it's paired with the occurrence data. And then the black is simply just areas where the model is predicting the animal to be, and the green is going to be areas of high probability, and then the red or white is areas of low probability. So MaxEnt was tied in with all of these things, and then all these things combined together give us our model, and that's what we're here to talk about. So simulated mink occurrence in Ohio. So on the left-hand side, we have predicted infected mink, strictly based off occurrence data and climate data and whatnot. And then on the right-hand side is going to, all those black dots are going to represent the mink farms here in Ohio. So as you can kind of see, it doesn't really change the probability where mink are going to be. But that does change when we add in a fake infection of mink. So here you can kind of see all these black dots are going to be another variable, which is fake infected mink. When you put that in, the green area does change. The central area is kind of green rather than white where it was before. And we combine this data with human COVID-19 data from September, and we created a map in ArcGIS.
So this is going to be the first map, and it's going to be COVID information with mink in Ohio. And So here's the legend, so we'll just go over briefly. So these white squares are going to be the mink farms, and then the redder the color is going to be the higher the case count of COVID. So the urban areas such as Columbus, Cleveland, Akron, Canton, etc., are going to be a lot more concentrated with COVID infections. And then the bigger the mink, the larger the likelihood a mink will be there at any given point in time. So you can kind of see that this whole central area of Ohio. So this is going to be the first map, and it's going to be COVID information.
Pardon that. We also created the map in ArcGIS for deer as well, and similarly R as well. White-tailed deer are very prevalent in Ohio. They're all over. They're our state animal, and we wanted to concentrate specifically on Northeast Ohio. So when we did our infections, we simulated all our deer to be in Northeast Ohio. So the left-hand side is our infection in R. You can kind of see all the deer tend to stay in Northeast Ohio, whereas the mink, they kind of spread out. We did the exact same thing in ArcGIS with deer, as well as pairing it with human data.
So similar to the mink map, this is just going to be Ohio, and it's going to be the simulated infection data overlaid on top of the COVID data that we already have. And as I previously mentioned, the COVID data is going to be for the month of September in Ohio. So you can kind of zoom in. We're going to see again that all the urban areas are going to be the most dense with COVID infections. And then the simulated infections going to kind of move more towards central Ohio, similar to the mink, but not as far, and this is probably because we simulated most of the infections to be in northeastern Ohio.
Great. So for future areas of research, we are hoping to adapt our model to include other animals such as the bat. We're particularly interested in the bat because the bat is thought to be one of the first reservoirs for COVID-19 and its transfer to humans. We're also interested in adapting the model to create to fit other pathogens such as influenza, as well as maybe even adapt it to be fit for other climates or continents, even countries. And we hope to do all of that in the future. So if you have any comments or questions, please post it here. And I thank you all for your time.